Hello, welcome to today's lesson. What we're going to do today is, as usual, a couple of starters, and we're then going to go over what we've done on Monday and Tuesday and then mix them up a bit to make sure you know which kind of factorising to use when. Okay, so you'll probably find that quite useful. Okay, so starters, remember, pause it if you know what you're doing. If not, stick around. So, first question. We've got 3/4 of this bracket. So remember, BODMAS, bracket first. So we need to work out this bit before we do anything else. So we're going to do 7.3, take away 2.58. And remember about getting your columns in the right place by putting your decimal points in a nice neat column. Okay, remember when you're adding and subtracting, you can fill in any spaces with zeros. So we're doing 0 take away 8, which can't be done in this context. So then we've got 10 take away 8 is 2. 2 take away 5 we can't do, so we're borrowing again. 12 take away 5 is 7. Keep your points in a line. 6 take away 2 is 4. So that's 4.72 that we're going to find 3/4 of. So we need to do 4.72 divided by 4. So that gives us 1, and then 1 and 8. So 1.18, and then we need to do 1.18 times 3 to get the 3/4. So 8 3s are 24, 1 3 is 3, add the 2 is 5, 1 3 is 3, nothing to add, so that's just 3. We've got 2 decimal places in the question, so we need 2 decimal places in the answer, so the point goes there. So our answer is 3.54. Okay, next one, we're substituting. Find the value of x cubed times 3x minus 5 when x equals -2. Okay, so what we're going to do is wherever we see an x in this, we're going to replace it with a -2. Okay, so we're going to get rid of that x and put a -2 in there. I'm just going to put the -2 in brackets just now. Okay. Oops. So we know that's a 3. Hold on. There. Okay, right. So now we can start multiplying. So at the start, we've got -2 cubed. Remember, that means -2 times -2 times -2. So -2 times -2, that would give you +4, times -2, +4 times -2 is -8. So you've got a -8 outside the bracket, and inside the bracket, we've got 3 times -2, so we've got -6, and then take away 5. So we've got -8 times, the value of the bracket now is -11. 8 11s are 88. A negative times a negative makes it a positive, so the answer there is 88. Okay, so let's look where we're at and where we're heading to. So on Monday we looked at factorising expressions using common factors, and yesterday we looked at factorising using a difference of 2 squares. So before we go on to our next kind of factorising, what I want us to do is practice both of these, common factors and difference of 2 squares, and then I've got a few questions where you have to look at them and decide which kind of factorising you're going to use. Okay, so common factor to start with. So let's find a nice colour. Blue. Okay, right, so remember when you've got letters and numbers, you need to be looking at them separately. So when we're looking at 5 and 20, then we need to find the highest common factor of 5 and 20. That's the biggest number that goes into 5 and goes into 20. So that's 5. Okay, and then looking at the letters, we can see we've got a c squared here and a c here. And the biggest thing that goes into c and c squared is c. Okay, remember what you're trying to put outside the bracket is the biggest thing, so that when you multiply out the bracket, you get what you started with. Okay, so inside this bracket then, 5c times this thing has to give us 5c squared. So that means that needs to be a C. And then 5C times this thing has to give us minus 20C. So it's going to have to be a negative. 5 times 4 is 20. And that's all we need there, because if we put any C in here, in there, then that would be 5C times 4C. That would give us a C squared, and we don't need that. So 5C times negative 4 is negative 20C. So that's that bit done. Okay, that's that question finished. Right, next one. Again, numbers and letters separately. So we're looking at the highest common factor of 18 and 12. So the biggest number that goes into 18 and 12 is 6. And when we're looking at the letters, we've got an M here and an M cubed here. The biggest thing that's going to go into M and M cubed is M. Okay, so 6M times this term here has to be 18M. So 6M times 3 is 18M. And then we need this term here. When we do 6M times this one, it's going to give us positive 12M cubed. So for a start, we need a plus. 6 times 2 is 12, and M times M squared is M cubed. Okay, you can always check these by multiplying out again. Okay, 6M times 3 is 18M, so we've got that. And 6M times 2M squared is 12M cubed, so we've got that as well. All right. And the last common factor example, again, the numbers, the highest common factor, the biggest number that goes into 24 and 20 is 4. Then if we have a look at letters, we've got x and x squared, so we've definitely got an x in both of those. And we've also got a y in both of those. So that's our highest common factor. And then inside the bracket, 4xy times what we're putting at the beginning has to be 24xy. So that must just be 6. And then what we put at the end of the bracket has to multiply by 4xy to give us negative 20x squared y. So we need a minus. 4 times 5 is 20. X times x is x squared. And we've already got the y. And we can just check that by multiplying out. So 4xy times 6 is 24xy. And 4xy times 5x is 20x squared y. And we've got the negative in there as well. So we're all good. Okay. Right, so that was common factor. Then switch your mind back to yesterday when we were doing a difference of two squares. So remember the rule is that if you've got a squared thing, take away a squared thing. Whatever's squared to give you the first thing goes in the beginning of the brackets. Whatever's squared to give you the last thing goes in the end of the brackets, and you have a plus and a minus. Okay, so first example then, x squared minus y squared. So it is a difference of two squares because we've got a squared thing take away another squared thing. The thing that's squared to give us x squared is just x. So we put x at the beginning of the brackets. The thing that's squared to give us y squared is y. And we need a plus and a minus. We can check this by multiplying it out using one of our methods for multiplying out brackets. Okay, so the next thing. Let's have a look. We've got a difference of two squares there. And if we have a look here, the thing that's squared to give us 4v squared, so 2 squared is 4 and v squared is v squared. So that's 2v squared there and 5 squared there. So that means that we put 2v at the front of the brackets, 5 in the end of the brackets, and a plus and a minus. All right, and then the last one, the thing that's squared to give us 9u squared. So 3 squared is 9, u squared is u squared. And then we've got 10 squared is 100, and p squared is p. So what we've got here then in our two brackets, we've got 3u in the front of our brackets, 10p in the end of our brackets, and then a plus and a minus. Okay, so if you've got a squared thing, take away a squared thing, it's a difference of 2 squares. Okay, so difference, remember, means subtract. 2 means you've got 2 terms, and squares mean the terms both need to be something squared. All right, so we're going to look at a mixture of those just now. Only 5 to do. I'm keeping this lesson quite short today. Okay, so these are mixed examples. So when we have to factorise these, so the question would say that, factorise. So when we have to factorise these, we first of all need to check, is it a difference of 2 squares or is it a common factor? Or, you know, when we get onto our other kind of factorising, we'll need to check that as well. So first of all, let's look and see if there's a common factor here. So there's not a common factor in the numbers because we've got 18 and 25, but there is a common factor in the letters because we've got a P in both of those. Let's think if it's a difference of 2 squares. Well, P squared, that's squared, but 18 is not a square number. Remember our list of square numbers? 16 is a square number, and the one after that is 25. So this is not something squared. Okay, 25 is 5 squared, but the P is not squared. So neither of these 2 terms are actually squared terms, so we're going to have to just go with a common factor, and the only common factor that we've got there is P. So our bracket would be 18P, because we want it to multiply with our P to give us 18P squared, and then minus 25. Okay, so that's that one done. Right, let's look at the next one. Let's think about common factors. So looking at the numbers, 81 and 25, I can save you a job by telling you that there aren't common factors there. We don't have common factors in the letters because we've only got P in this term. So let's think if it could be a difference of 2 squares. Well, remember 81 is a square number, that's 9 squared. And P squared is P squared, so that's 9P squared. And 25 is 5 squared. So, and we've got a difference in the middle here, so that means that it is a difference of 2 squares. So we can set up 2 brackets with 9P at the beginning of both and 5 in the end of both, and 1 plus and 1 minus. Okay, looking at the next one, looking at our numbers, 36 and 49, again, no common factors there. It is a difference because we've got a minus in the middle. 36u squared, well 36 is a square number, it's 6 squared, isn't it? So 36u squared is 6u squared. 49 is 7 squared. So we do have a difference of 2 squares, so we can set up our 2 brackets there. And then we've got to put 6u in the front of both brackets, and 7 in the back of both brackets, and 1 plus and 1 minus. Okay, right, the next question, I'm actually just going to change that number to 3. Okay, so let's have a look then. When we're checking, when we're checking these, we need to see, is there a common factor? We need to see if it's a difference of 2 squares. Now, if we have a look at this, it is, these things are both squared, aren't they? So this is 5d, this is 5d squared, and that's 6e squared, but it's not a difference. Okay, so actually we can't factorise this because in 25 and 36 we have no common factors, and the letters, we've got no common factors there, so this one won't factorise. Okay, so it's not a difference of 2 squares, and remember that's because that's a plus. It has to be a minus for a difference of 2 squares. Okay, and then the last one, well, 100 is a square number, so we've got 2 terms and we've got a difference, so it might be a difference of 2 squares because 125 are both square numbers, but n isn't squared, so that is not a difference of 2 squares because this isn't squared. Okay, so what we need to look at is common factors. So looking at 125, the biggest number that goes into 125, sorry, not 125, is 25. And then we've got n and n squared, so they've both got an n in them. So in our bracket, we would have 25n times this gives us 100n, so that must be 4. And then a minus, and 25n times this has to give us 25n squared, so we only need an n there. So that was all I really wanted to go through today, was just to recap on common factor, recap on difference of 2 squares, and then make sure you know how to spot which is which. Okay, so remember, a difference of 2 squares does what it says on the tin. It has to be a difference, so it's got to be a minus. It's got to be 2 squared things either side of your minus. Okay, when it's a common factor, there has to be a common factor of both terms. All right, we will look later on at questions where we've got both a common factor and a difference of 2 squares. So I want us to be really secure in what we're doing with the basic factorising first though. So I'll put some practice questions up for you and yesterday's solutions, and I will see you later.